Okay, so take out your pre-lab force and then record the answer, write the answer when I'm discussing. All right, when I go through the answer with you guys. Okay, so experiment 4 is a rotational motions of a rigid body. It is a chapter 8 in your syllabus. Okay, yeah. Okay. So course learning outcome as usual, this one is just tells you what is the things that you need to know at the end of the course, which is at the end of this semester. So the learning outcomes, okay, so the learning outcome at the end of this section, okay, students will be able to explain the experiments to determine the moments of inertia of a flywheel. Okay, the moments of inertia of a flywheel from the experiment. So what is a rigid body? Okay, so this is the pre-lab. First of all, it asks you to define, because first you must know what does it mean by rigid body and what does it mean by moments of inertia before you start the experiment. Otherwise, you don't know what is the things that you are calculating. So a rigid body is a body that has a fixed shape. Okay, fixed shape where it does not change its size and shape when you have a force exert on it. Okay, so usually it's something that is hard. So a liquid obviously is not a rigid body, and then the air is not a rigid body. Okay, so rigid body is something that is hard, that won't change the size easily. Now, what is the meanings of moments of inertia? So moments of inertia is something that is very similar to the inertia in our chapter 3. Okay, it is a tendency of an object. So if you look at the definition, it says it is a tendency of a body to resist angular acceleration, and then express that as a sum of the products of the mass of each particles in the body and the square of its perpendicular distance from the rotations of from the axis of rotation. So basically, this is the equations. Okay, so starting from the express here, then it tells you what is the equations of the moment of inertia. But basically, the definition is to resist. Okay, to resist the changes, to resist the angular acceleration, as we learn in chapter 3. So when you have something that is moving, it won't change its speed easily. And when you have something that is not moving, it won't start to move easily. Okay, it means it doesn't want to accept any changes on its acceleration. So in a moment of inertia, it doesn't want to change its motion as well. It is a tendency to resist angular acceleration. So angular acceleration, again, is about self-rotation. All right, acceleration is something happens in a linear motion, and then angular acceleration is something happens in a rotation. So when you have the terms angular, means it's happening in a rotation, right? So you have a what? You have a displacement, angular displacement. So angular displacement is about the rotation, the circle. You have a velocity, you have angular velocity, all right? And then you have accelerations, you have angular accelerations. So basically, the variables, the terms without angular, it refers to the linear motions. The terms with angular, it refers to a rotation. Okay, it refers to rotations. So what is a symbol and an SI unit for moments of inertia? So it is the kgm square. All right, because if you look at the definition, what does it tell you? It tells you the sum of the mass of each particle. So it's the sum of the mass and each particles and times the square of the distance, okay, that is from the rotations axis. So summations mr square. So I equals to summations mr square. That's why the unit, okay, is kg m square. So this is the equations for moments of inertia. So I is a moments of inertia. So moments of inertia, according to its definition, its equations, it depends on mass and the radius from axis of rotations, or you can say the distance, okay, the distance from the axis of rotation. So complete table 4 with the correct analogs between linear motions and rotational motions. Now, basically, chapter 8 is the combinations of chapter 1 until chapter 5. The only difference is you change its variables. Okay, you change the symbol. So for example, in chapter 4, mass, we call this as m. But in chapter 8, our mass is actually our moments of inertia. So they represent similar things, but in a different terms. One is in a rotational motion, and another one is in a linear motion. So another one, if you look at the equations, okay, you look at the table, linear motions, accelerations, we call it A. In the rotational motions, we just add an angular in front of it, so it's angular acceleration. Chapter 4, okay, in the linear motion, the force, okay, we call it F. The external factors that causes the object to move is a force. In a chapter 8, the things that causes the object to rotate is torque. Okay, basically it's some things like rotational force. Okay, but it has a new name called torque. Okay, so with a symbol torque. So they are very similar. Now, in that case, what can I say about the rotational motions? In chapter 4, we know F equals to ma. Okay, since we say they are very similar to each other, basically you just change the symbol, okay, so that we can use it in rotational motion, which means torque actually can be written as I alpha. Okay, I alpha. Why? Because torque is analog to F, I is the analog to M, and then alpha is analog to A. So basically, you just replace the symbol with the symbol in rotational motion. Okay, with the symbol in rotational motions. So in another words, what does it mean? If you recall the equations that we have in chapter 2, okay, we have V equals to U plus AT, V square equals to U square plus 2AS, S equals to UT plus 1 over 2AT square, S equals to 1 over 2U plus VT. So basically, okay, if you look at the things that we just try, okay, we can transform the equations in linear motions into rotational motion, which means these 4 equations, we can also transform it into equations for rotational motion. How? So in that case, you have to think, what is the analogs for UVAS? So V in chapter 8, we call it omega, our angular velocity. So U, of course, is also omega, but now we add a note for it, okay, to indicate that this is initial angular velocity, final angular velocity. So omega is final, omega naught is initial. S is a displacement, so the analogs would be angular displacement, okay, and then A, we have just seen it. So the analogs for A, acceleration, is angular acceleration. So time is just a scalar quantity, so we don't have to change its symbol. Okay, times, it doesn't matter whether it's in a linear motion or it's in a rotational motion, you are still going to have the same symbol. So what am I going to do now if I want to transform these 4 equations into the equations in rotational motion? So basically, I just replace the symbol. So V, I replace with omega, and then U, I replace with omega naught, A, I replace with alpha, and then times, I keep it as a T. So that is the equations that I'm going to use in chapter 8. All right. So the second equations, V, so omega, U again, omega naught square plus 2A, I'm going to change it to alpha, S is a theta. Okay. So basically chapter 8, like I told you, is some things that you have been learning since chapter 1. So what are we doing in chapter 8? We just try to think, okay, what happens in the rotational motions. We are just going to learn what happens in the rotational motions and how to use a new set of equation. Okay, and all those equations actually is coming from linear motion. The only things that we are doing, we replace it with a new symbol. Okay, with a symbol that is analog to the linear motion. So next equations, S, so theta equals to U is our omega naught, T plus 1 over 2 alpha T squared. Last one, theta is equals to 1 over 2 omega naught plus omega T. So basically some things that you have learned in chapter 2. Okay, that's why I gave you the video already in the lecture, so you can go through it now. It's some things that you have been learning since chapter 1. All right, the only difference is just a symbol. And just a few new things, for example, the rotational in equilibrium in rotational motion. Okay, so you can watch the video already when you are free. Okay, now let's go back to number 6. A motor capable of producing a constant torque of 100 Newton meter is connected to a flywheel which rotates with an angular accelerations of 1000 radian per second squared. Calculate the moments of inertia of the flywheel. So you are given the torque, and then you are given the alpha. So it asks you to calculate moments of inertia. So by using torque equals to I alpha, you rearrange the equations. I equals to torque alpha. Okay, therefore you obtain the I, which is something like the mass. Okay, something that acting like a mass in torque. So it's 0.1 kg m squared. Okay, now let's go to the experiment. So this is a report that you have to do this week, okay, this week. So what am I going to do with you guys? I'm go through all this with you, and then you complete the lab report and submit it before 5 p.m. on Sunday. Okay, your experiment 3, you need to submit it before 5 p.m. tomorrow. Your experiment 4, you need to submit it before 5 p.m. on Sunday. So you have 2 days. You still have 2 days to do it. And in experiment 4, I don't want you to do a complete report anymore. Okay, you can skip the procedure, you can skip the theory, you can skip the list of apparatus. What I want you guys to do is just a title, objective, and then straight away proceed to observation, discussions, and conclusion. Okay, we are going to follow the report writing test format. All right, so that one I'll explain it to you after this. Now let's look at this bullet point number 7. So sketch a free body diagram for flywheels and the following slotted mass. So the free body diagram for flywheel, basically you can just copy it down. Okay, for flywheels, you still have to draw the wheels. It's unlike in a chapter 4, where we use a dot to represent the force. Okay, in chapter 8, you still have to draw the basic shape of the object. So the free body diagram of a flywheel, you need to draw a circle first, and then the force is a tension. Okay, you have a tension. So you have to label the directions of angular acceleration. So angular acceleration is the rotations, right? So angular acceleration, this is the directions. Okay, it rotates. So basically, that's it. Okay, it's very simple. It's very simple. And then for a free body diagram of a slotted mass, okay, now the diagram given in the answer scheme is a slightly incorrect. You should use a dot to represent the object. So make sure you are clear. In chapter 8, you can use simple shape to represent the object because you are talking about rotation. You need to know the directions of rotations. You need the shapes. But in chapter 4, still we are going to use a dot to represent the object. So object come with weight. You have a W going down, and then it's being hung by a string. So you have a tensions. So A is going down. So that is a correct free body diagram. This is wrong. Okay. So free body diagram for a flywheel, you can just copy it down, and then free body diagram for slotted mass, then you use the one that I shows you. So by referring to the free body diagrams in a 7a and a 7b, deduce equations by using Newton's second law of motion. Now, if you look at the diagrams in a 7a, okay, your object is rotating. So when it's rotating, okay, we apply Newton's second law. So Newton's second law for a rotational body is summations torque equals to I alpha. It's just like your summations F equals to MA. Now you replace F with torque, M with I, and A with alpha. Okay, so So as usual, what are you going to do? So you substitute the I alpha here, and then TR minus torque. Okay, TR minus torque. So you have a rotational motion. Okay. Yeah. And then that manner.
Madam,
Yes.
saya boleh jawab apa tu? TR tu daripada mana?
Sekejap ya. Susah sikit nak terang kepada anda sekarang sebab anda belum masuk lecture lagi, okay? Because you need to learn the whole chapter in order to understand how to form that equations. Yeah, let me find something. See whether the theory got mentions or not. Okay, theory tak sebut. Alright, never mind. Let's go back to one just now. Okay, so basically, I think there is something wrong in the equations given. It shouldn't be TR minus torque. Okay, it should be just a TR. Wait, just hang. Okay. So it's just a TR, okay? It should be a TR equals to I alpha. So basically, it's same things like what happens in chapter 4. You are looking at the force that causes the object to move. So in a flywheel, you are looking for the force that causes the object to rotate. Okay, in which, if you look at this diagram, the force that causes the object to rotate, now, torque actually other than torque equals to I alpha, the definitions of torque is actually equals to FR, okay, FR. So same things, okay, you want to transform from linear motions to rotational motions, you add an R in the equations. So for example, as you want to change it into a rotational motion, it is equals to R theta, okay, and then omega V equals to R omega, right? And then so what do we have? Some more, we have a R omega, bukan R theta. Then A is equals to R alpha. So basically, okay, when we want to connect linear motions and rotational motions together, usually we add an R in the equations, okay, it radius. So that is the main difference between linear and also the rotational motions. So for torque, okay, for torque, the definitions for torque is actually F times R. F is a force, okay, it's a force that is, I would say that's perpendicular to the radius in this flywheel. Okay, in a flywheel, force is a force that is perpendicular to the radius. So torque is equals to F times R before you apply it into the Newton's second law. So basically, if you look at the rotational, the flywheel, the force that causes my object to rotate is what? Is the tension. Okay, therefore, tension is a torque. Tension generates a torque that causes my object to rotate. And the torque generated by tension, I calculate it by using T times R. Okay, I calculate by using T times R. So tension causes a torque. Okay, generate the torques, and this torque generated by tension causes the object to rotate. Therefore, torque you can calculate it by using T times R. So this is the definitions of torque. Okay, this is based on the definition. So just now, okay, the equations that we are looking at is a Newton's second law. Okay, it's coming from Newton's second law. So now this one, torque equals to FR, is a definition. All right, torque sama dengan FR adalah definitions untuk torque. It tells you what is the force that causes the object to rotate. That's why you have an F in the equation. This F actually is the force that causes the object to rotate. So you use this force to calculate the torque. Okay, and the torque will tells you the tendency of the object to rotate. If you have a very high torque, then object is easier to rotate. If the torque is small, then it will be hard to rotate the object. All right. So let me rephrase it again. Torque is it tells you the tendency of an object to rotate. Okay. So how to determine the torque? So torque is being generated by force. Okay, so you try to search for the force that causes the object to rotate, then you use that force to calculate torque. And from that value, you will know whether that object can be rotated easily or not, right? So in this case, the force that causes my object to rotate is tension. Therefore, I use tensions to calculate torque. So torque equals to TR. And we have only one force that causes the object to rotate. Therefore, when you substitute it into the equations, what are you going to do? So basically, it's like your second law. Your second law, you start from F equals to MA, and then you try to search for the force that causes the object to accelerate. Here, same things happen. Okay, you keep the I alpha in the equation, just as we keep the MA in the equations. Then what are we doing? We expand the equations on the left-hand side. So in this case, we expand the summations torque. We try to look for the force that causes my object to rotate. We try to look for the force that generates torque in our object. So in our diagram, T is the force that generates torque. Therefore, I use TR on the left-hand side. Okay, so TR equals to I alpha. That is our first equation. And then for the falling object, we use summations F equals to MA. So A is going downwards. Downward is positive. Upward is negative. Therefore, what happens here? I use W, which is mg minus T, equals to MA. So T equals to M bracket G minus A. So this is your second equations. So you have two equations. So in a assignment, usually you need to form these two equations in order to find the final answer. All right, usually when it involves a rotational wheel, flywheel, and a falling object, this is what you have to do. You form one equation for flywheel by using summations top equals to I alpha, and then you form another equation for the falling object by using linear motion equations. Okay, so one rotational motions, one linear motion. The idea is very similar. You apply second law. Okay, just that the second law is in terms of rotational motion, which is summation top equals to I alpha. Another one, the second law is in terms of a linear motion, which is summation F equals to MA. And then the way we expand the equation is exactly the same. One, you search for the force that causes the object to rotate. Another one, you search for the force that causes object to accelerate in linear motion. All right. Okay, so we got the two equations based on the diagram. Done. Okay, basically that is what it asks you to do. So for this experiment, identify the manipulated variable. Now, because you are changing the mass, the hanging mass, okay, the mass of the hanging slotted mass. Therefore, that is your manipulated variable. Okay, you control the mass of the falling object. And the responding variables, you record the time taken. So the experiment that you are doing in this experiment for is something very simple. So here you have a flywheel. Okay, so what happens here? Now you hang the mass. Okay, you hang the mass. So this is your slotted mass. Okay, this is your slotted mass. So what happens? Okay, you use different mass and then you record the time for it to fall down. Okay, for it to drops until the soft board, until it hits the soft board here. So this is a soft board. And then this is your flywheel. And then this is a mass. Okay, the slotted mass. So you are controlling the mass. You want to record the times for the different mass to drop from a certain height. Okay, so you have a same h. So every time you repeat the experiment, okay, you add one slotted mass or two slotted mass. Okay, you manipulate the mass and then you record the falling time. So that's it. That is experiment 4. It's a very, very simple and easy experiment. All right. So a complete observations table with a suitable equation. So acceleration is A equals to 2h over t square. This is how you calculate the acceleration in the experiment. And then angular accelerations can be calculated by using alpha equals to A over R. Tension is T equals to M bracket G minus A. Basically, it's based on the equations that you formed just now. Okay, so you simplified it, and that is the conclusions that you get. Okay, these equations, and also this one. Okay, this is the relationship between A and alpha. So tension in the string is based on the equation just now. Okay, it's based on the equation just now. Well, we have W minus T equals to MA. So mg minus T equals to MA. T equals to mg minus MA. So you factorize it out. Mg minus A. So this is based on the second equation just now. So accelerations and angular accelerations, like I told you, A is equals to R alpha. Therefore, rearrange the equations, you obtain alpha equals to A over R. So acceleration A equals to h over t squared. This is given in the theory. All right, this is given in the theory. So data analysis. Now write the equations of the graph of alpha against t. If you go back to the lab manual, this is the equations given. All right, this is the equations that you need to use in your calculation. So because question asks you to sketch a graph of alpha against t. All right, therefore the equations that will come with alpha and t is these equations. Now you have these equations. What are you going to do? As usual, you compare with y equals to mx plus c. Okay, let's look at the pre-lab first. So write the equations of the graph of alpha against t. So based on the theory, we know that alpha equals to r over I times t minus top over I. So based on the linear graph equations, like I told you, you always have to compare with y equals to mx plus c. And you must know how to do the comparison. Why? Because in your practical test, in your report writing test, you will be given a brand new experiment. The experiments that you haven't tried in SEM 1. Okay, you didn't do in your SEM 1, experiment 1 until experiment 6. Okay. We have never tried that question. So it is a brand new experiment. Therefore, you yourself have to know how to do all this comparison. You yourself have to know how to identify which equations to use. So you search in the procedure, see what type of graph that the questions want you to do. So obviously this one, it asks you to sketch a graph of alpha against t. Then you go through the theory, you try to search which equation contains alpha and t. Do you need to rearrange the equations or not? Because some experiment, you need to rearrange the equation in order to get an equations that fulfill the graph, okay, the motions, the axis of the graph. So you yourself have to know, okay, which equations to use, whether you need to rearrange it or not into the forms of y equals to mx plus c. All right. So here I can still show you, but in your report writing test, I cannot help you because it's a brand new experiment. So alpha equals to r over I times t minus tau over I. So based on the linear graph equations, you have y equals to mx plus c. So we are going to do comparison. So alpha equals to r over I times t minus tau over I. So do you have to rearrange the equations? Obviously no. Why? Because when you compare it with y equals to mx plus c, you can see that, okay, now A is in the y positions of y, which is correct because you have a alpha against t, which is y against t graph. Okay, y against x graph. So which tells you your y is actually your alpha and your x is the tension. So if you look at the equations, now tension is also at the correct position. Therefore, you don't have to rearrange the equations anymore. Okay, so alpha and t, both of them, they are at the correct position, means that now this equation is already correct. You don't have to rearrange it. If they are not at its correct position, then you need to rearrange the equation. All right, you need to rearrange the equations. So based on the comparisons, okay, by comparisons, we know that r over I is our m, and then negative tau over I is our c. You need to include the negative sign. Okay, you need to include the negative sign. So this equation, it got a slight mistake. It should be negative tau over I. That is our y-intercept. It will be in negative value. So in which it means if you sketch a graph for this experiment, by right, you should have a negative y-intercept. Okay, this is your y-intercept. Based on the equation. Okay, this is a correct graph. So when you sketch a graph for this experiment, make sure you leave some space for the negative axis. Okay, maybe 1 or 2 boxes they are enough. So jangan bermula tepat-tepat pada hujung graph kamu, okay? Pada bottom line dia. Kamu biarkan satu kotak atau 2 kotak, baru kamu start kamu punya x-axis. Alright, because why? Because now you should have a negative value, negative y-intercept, based on the equations given. All right, based on the equations given, you will have negative y-intercept. So you leave 1 box or 2 boxes before you draw the line for x-axis. So by comparisons, okay, let's go back to 12, number 12. So by comparison, y-axis is alpha, x-axis is t. So this 2 actually is coming from your graph. Okay, it's coming from the graph, not just from the equation. So gradient is r over I, and then y-intercept is negative tau over I. Okay, it's negative tau over I. So how do we determine the values of inertia of a flywheel from the graph? It's from the gradient. Okay, from our linear graph, we determine the gradient. So m equals to r over I. Therefore, I is equals to r over m. So radius, you measure it in the experiment. Okay, you measure the radius of flywheel. So just now we have a flywheel here, right? So you measure the radius by using a vernier caliper. Okay, so this is a radius. So these 3 precautions, okay, these 3 precautions, I don't want you to follow it, okay? I want you to follow the way that I taught you since experiment 2. Okay, explain. Don't just tell me make sure. How are you going to make sure? This is a very poor precaution. Okay, so avoid any external force. How? Okay, all this how to achieve it. All right, if you follow the answer given here, then I'm going to give you wrong. Okay, you need to explain how. Don't just give me 1 sentence. If you write this in your university lab report, believe me, the prof will throw the lab report into your face. Okay, dia akan terus campak ke muka kamu. Kalau kamu bagi satu ayat begini, make sure the slotted mass is released from a fixed height. Itu bullshit bagi saya. Because there are some things that you should do. What you should tell is how to achieve it. All right. So done. That is your pre-lab 4. Okay, pre-lab 4. So far, any questions? Other than dua equations ini, mungkin susah sikit nak faham. The rest, okay?
Okay, madam.
Okay, so number 8, you have to go through the video first, okay? The video in the lecture. So when you have times, you just watch the video first. Okay, and then the rest, I believe, should be simple. Everything is coming, okay, especially from the data analysis, is coming from your lab report. Okay, it's coming from lab report. It's something that you have been doing since experiment 2. All right. So now experiment 4, okay, I want you to do it. And then what do you have to include in your experiment 4? You start from a title, and then objective, okay, and then observation. So in the observations, of course, you need to have a table. Okay, and then so after that, you do the simple calculation. Okay, so for example, the calculations for what? The calculations for your centroid, the calculations for the gradient, and so on. And then, of course, you need the graph. Okay, so you need you need this 3 item in your observation. And then give me your discussion. Okay, so discussions, again, first paragraph, remember in paragraph, don't give me in point form anymore. First paragraph, okay, discuss your results. Okay, discuss your result. So as usual, how to discuss the result? You discuss, okay, maybe in terms of the experimental value and the standard value, and then the percentage of error and the percentage of difference. Okay, I haven't checked the values, the data yet, because they just added it into the fee board yesterday. All right, so the data, I haven't checked it. If you have a standard value, then you need to calculate the percentage of error, the percentage of difference between experimental value and standard value. All right, and then you comment on it whether it is accepted or not. Like what I told you, is based on the 20%. Okay, it's based on the 20%, and then you give a 2 error and also 2 precaution. Okay, 2 precautions. So 2 error, 2 precautions, you must explain a little bit. Okay, and actually I want to change the phrase a little bit. Rather than precaution, I want to change it into suggestions. All right, so this is your report writing test requirement. Okay, kamu dengar elok-elok ya. It is no longer like your precautions that we discussed before. Some things that you did before you conduct the experiment. This one is more on what is the errors that you identify in the experiment, and then you give suggestions that is related, must be related. Okay, must be related to the experiment, to the error, sorry, must be related to the error. Okay, so 2 sources of errors, and then 2 suggestions to overcome the error. Okay, and then in the new format, it asks for 1 more paragraph. Okay, so now this error and these suggestions, it will be the 3rd and 4th paragraph. You need to add in a 2nd paragraph. You need to add in a 2nd paragraph where you discuss at least 1 precaution. So this 1 precaution is something, okay, something you do before experiment. For example, you switch off the fan. That is one of the precaution. Okay, that is not the suggestions to overcome error. Because if you're in my lab, in an actual lab, what I'm going to do, I will ask you to switch off the fan in every single experiment. So that is not a suggestions. Okay, that is more of a precaution. So now in this new format, what it wants you to do, now you have to change it into 4 paragraph. No longer 3 paragraph, okay? 4 paragraph. Paragraph 1, discuss your result. 2nd paragraph, you give 1 precaution. Okay, you give 1 precaution. And then third paragraph, 2 errors. Fourth paragraph, 2 suggestions. Okay, so dia tambah sikit benda. Okay, dia tambah sikit benda. Right? So discuss, okay, as usual, you discuss your result. For example, so you mention the result and then the percentage of error, okay, or the percentage of difference. And then the thing that you must have now is a comment, whether it is accepted or not, right? Comment, okay, comment whether it is successful or not. Comment whether it is successful or not, based on the 20%. Okay, so now this has become a must to do. Okay, something that you must do in your discussion. So not just not just the result and percentage of error and the percentage of error anymore. You also have to comment whether it is successful or not. And then the new things that you need to include in your lab report is a precaution. Okay, dia tambah lagi satu precaution. So this is the new format. All right, this is a new format. So they add more thing in the discussion. So discussion used to be just 6 marks. Now it has been increased into 10 marks. Okay, 10 marks in your report writing test. Dulu-dulu dia 6 markah saja, sekarang dia jadi 10 markah. Because it asks for more things. Alright, and then conclusion. So conclusions, you just state, as usual, whether it is accepted or not. Okay, or whether the objective is achieved or not. Refers to your objective. Okay, refers to objective and then discuss whether it is achieved or not. All right, so now, okay, the new format, altogether, your lab report is 40 marks. Okay, and 40 marks will be converted into 15. So 1 mark is coming from your title. Okay, satu markah untuk title. If you write it down correctly, 1 mark is for the objective. And then, now, so what do you have? The data tabulation, which is a table, is now 6 marks. Quite a lot of marks. And then, calculations, your calculations for centroid, gradients, and also the required value now is 10 marks. Okay, 10 marks for the calculations. Graph, correct graph and everything is 11 marks. Okay, and then discussions 10 marks, conclusions 1 mark. So this is the new format. All right, this is the new format. So what I want you to do in the following experiment, in experiment 4, you do it follow this format. All right, experiment 3, you still use old format. You don't have to change anything. Experiment 4, I want you to do it according to this format. Okay, boleh faham? Ada part mana yang tak faham? Especially the discussion. Discussion, 10 marks is quite a lot. If you got it wrong, then most probably you're going to fail your report writing test. Okay, so boleh faham semua ini. Okay, hopefully you can understand. Okay, you do it carefully, especially in terms of your discussion. Okay, in terms of the discussion. Okay, now we still have 20 minutes. What I want to do, okay, I have a 1 lab report from your class. Okay, so Lai is a very good. Okay, she is the one that submitted she is the only one that submitted so far the lab report 3. All right, now talk about submissions. Okay, your class got a lot of people don't like to submit my works on time. Okay, ramai sangat yang submit late. And there are a few of you who have never submit my works. Tak pernah submit. Okay, so it's a very, very bad things. Okay, tak bagus. Yeah, let me see. So I'm going to show you who have done it nicely, who haven't done this nicely. Wait, stop presenting. So Windows, let's see. Okay, tengok. So lab report, okay, this one, tick means I've already marked and returned it. Okay, so yang pertama, okay, so Anis, the second lab report, you're late. Okay, and then, okay, Howard, your first lab report is incomplete, yeah? So for those incomplete, I will put a comment in your works. Okay, in the comment section. Okay, so ada lagi, done late. So some of you submit on time, every time, which is very good. So Irfan, tak pernah submit kerja saya, never submit. Okay, you see all this late, dah biasa dah late and late again. Haziq tak pernah submit kerja saya. Munira also haven't submit your second lab report. Okay, so everything I have a record here. Okay, who submit late, who didn't turn in my works. So of course, most of you're quite good. Okay, you submit on time. Just a few of you who are late. So experiment 2A tak ada masalah because I changed platform. So you submit late, that is fine. But for experiment 2, actually you shouldn't submit late. Okay, so ada yang submit late lagi and then ada yang missing. So Irfans and Haziq tak pernah submit kerja saya. Ada dalam kelas kah? Tengok Asad. Okay. Yeah. Irfans ada, Haziq ada. So where is your work? Mana kerja Irfan dan Haziq? Yeah. Oh, ada dua Haziq. Yeah. Okay, so mana kerja kamu? Okay, so all this report, I will keep it here. So in case you want to apply anything, I will refer to this one before I give feedback. Because sometimes HEP and pihak pengurusan, they will ask for comment. So if this one, okay, all this record, they are very bad, for example, all missing, all late, then perhaps I won't give you a very good comment. Okay, I won't give you a very good review. So make sure everything's here, they looks nicely, they looks on time. So experiment 3, you still have time, okay, because the deadline that I set is, let's see. Okay, there. Due tomorrow, your lab report number 3, and then due Sunday, your lab report number 4. Okay, lab report number 4, I give you until Sunday because you don't have to write the theory, you don't have to write the procedure, you don't have to sketch the diagram anymore. What are you going to do? Is some things that I show you just now. Okay, you just do all the calculations. You focus more on the calculations and also on the discussion. Okay, calculation and discussion. Discussions basically is very similar to what you have been doing, just that you have to add in one more precaution. All right, so remember, error is something that cannot be avoided in the experiment. Precaution is something that you have done before you start the experiment. So one of the very typical example is you switch off the fan in SEM 1, because fan will generate the airflow, okay, will cause the air to flow, which then give you inaccurate result. Okay, I won't say incorrect, but it's less accurate, right? It's not that incorrect, it's just less accurate. So be careful with the terms that you use in your discussion. If you say it gives you incorrect result, then what is the point of doing all those analysis, since you know it's incorrect? Okay, so it is not incorrect, but I would say less accurate. Okay, less accurate. So less accurate is acceptable. Why? Because experiment come with a lot of error. Okay, experiment come with a lot of error. Therefore, it is very impossible for you to get 100% accurate results. Okay. So now let's go through one lab report quickly, because there are some minor changes in the calculation. So I'm just going to proceed to the calculation. All right, I'm just going to proceed to the calculations. So calculations, this okay. So the first things I want to discuss is a table. All right. So table, let's see. So table, this one, the first one is correct. Okay, you got a H, you got an uncertainty. And then the time, you have 0.000001. Okay, 1, 2, 3, 4, 5, 6. Okay, you have a 6 decimal place. Now, when it comes to this table, all right, here you have uncertainty up to 6 decimal places. So all these values should be kept at 6 decimal places. All right, all this it should be kept at 6 decimal places. Now, the average, if you put it at a new column, then it's considered as a secondary data. Okay, so in this case, you just use 2 to 3 decimal places. Okay, 2 to 3 decimal places. If you put it in a new column. But some of the students, what they did, okay, this is how they do the table. So you have a H here. Oops. And then this is your V square. This is your V. So some students, what they did here, okay, they put here as a T1, T2, T3, and then this T average. Now in this case, if this is how you do it, then this T average need to be 6 decimal places. It follow your uncertainty. Okay, so because here you put T is plus minus 0.000001 second, therefore your T average need to be 6 decimal places. But in the tables, in this table, now you split it into a new column. You treat it as a secondary data. Okay, secondary data. Then it should be just 2 to 3 decimal places. All right, 2 to 3 decimal places. So to be more precise, actually, I would prefer you to use 3 significant figures. Because if this is your data, you use just 2 decimal places, then perhaps you're going to get all wrong. Okay, dia kurang sesuai. So usually when you have a data like this, okay, in your calculations, what are we doing? Actually, we change it into prefix form. Okay, so for example, the first one actually is 1.14 times 10 to the power of negative 2. Then the remaining term, they are all in times 10 to the negative 2 form. Then you still have 2 to 3 decimal places. Then the value would be very accurate. Okay, so this one is a 1.31. So 1.20. 1.10 times 10 to the power of negative 2. 0.10 times 10 to the power of negative 2. 0.09 times 10 to the power of negative 2. Okay, 0.9, sorry. Wait, yeah. Yeah, 0.9. So 1.0 and 0.9. And then, yeah. So you just keep going on, okay? Just keep going on until the end. So this actually would be a better way in writing down your result if it is very, very small. Okay, see, because now you have 2 0 here. Actually, if you use 2 or 3 decimal places, then you are going to get a very inaccurate result. But of course, if you are scared, then you just do what I show in the table above. Okay, you put T average as part of your time. Okay, then you can keep up 6 to decimal place, up to 6 dp. Alright, boleh faham? So kalau kamu letak di bawah T ini, okay, kalau kamu letak di bawah T sini, then your T average can have up to 6 decimal places. It must follow, actually. T average must follow the numbers of decimal places in your uncertainty. But if you split it as a new column, then it will be taken as a secondary data. So secondary data is a calculated data. Calculated value, you should have only 2 to 3 decimal places. All right, 2 to 3 decimal places. So if I'm not mistaken, okay, in your report writing test, now how they calculate the point, I think is one column is 2 marks. Kalau tak silap saya cuma tengok sekali sahaja. So I think this is 2 marks, this is 2 marks, this is 2 marks. Okay, so it means that there are 3 things you need to calculate in your report writing test. All right, if I'm not mistaken. So if you got this T average wrong, then you're going to lose 2 marks. All right, then your V and your V square, it depends. If you got all correct, then all right. If you got all wrong, then cannot lah. Okay, then cannot. So your V, okay, your V is 205,114. Actually, it's quite large, the value. Okay, so when you have a value that is more than 10, then usually we will put it in a power form as well. So this one, actually, it should be written as 2.05 times 10 to the power of 2. Okay, so 2.30 times 10 to the power of 2. Okay, so semua akan jadi darab 10 kuasa 2. Why? Because usually the values in front of the prefix, okay, we keep it at 3 significant figures. Kalau kamu perasan, semua saya guna 3 significant figures. Okay, so significant figures actually is a more appropriate method, more appropriate way in writing your report, in doing your lab report. Alright, so kalau ada 10, 12, 11 begitu, you can leave it. But when it's up to 100, then usually we change it into power. 2.05 times 10 to the power of 2, 2.30 times 10 to the power of 2, 2.52 times 10 to the power of 2, and so on. All right. So tak ada masalah. Okay, this one I just use it to explain. So v square, okay, v square is fine. So you got it correct. Okay, so very good. You know to change it into times 10 to the power of 4. So this is what you should do. All right, this is what you should do. So this is very good. So you have all this value in the 4.21, 5.26. So all correct because the decimal places is consistent. So now one table is worth 6 marks. So be extra careful with the table. Be extra careful with all the decimal places that you are using. Right? Okay, so centroid. Centroid now, if I'm not mistaken, it's also like, if I'm not mistaken, I think it's 2 marks each. Okay, kalau saya tak silap, this one 2 marks, this one 2 marks. Okay, so 2 marks is coming from where? Coming from equations and your substitution, 1 marks, final answer 1 marks. Substitutions and equations, 1 mark, and then your final answer 1 marks. So you must show the substitution. Okay, so this is a must. Okay, this is a must. Without this one, you won't get marks for your centroid. Okay, kamu akan hilang 2 markah ini because this substitution is a must. So you shows it and then you calculate with correct unit 1 mark. Okay, and then you substitute, you calculate with correct unit 1 mark. Make sure the unit is correct. All right, make sure the unit is correct. Right, and then as usual, you have a gradients and then you have a required value. So gradients and required value, okay, if I'm not mistaken, I think it's 2 or 3 marks for 1 gradient. Okay, so let's see whether you got the correct decimal places or not. Okay. So the graph. Oh yeah, when you start graph, make sure I can see the whole graph paper, yeah. So jangan ada part yang hilang. So this one is okay. So okay, so you have a 5 here. So the smallest is 0.5. Half of the smallest is 0.25. So it should be 2 dp for the x-axis. And then here I have a 1. So it's a 0.1. 0.1 divided by 2, 0.05. So also 2 dp. So 2 dp, 2 dp, yes, your substitution is correct. All right, substitution is correct. And then answer with correct unit, another 1 mark. All right, another 1 mark. So by comparison, so this is a part that you have to do by yourself in your actual report writing test. Okay, because you'll be given a brand new equation. So you yourself have to know how to rearrange it, whether you need to rearrange the equations, and then you compare with y equals to mx plus c. Okay, so by comparisons, you obtain m equals to 2g. I think this one you got 1 marks, and then you substitute with correct value, and then you do it with the correct calculations, another 1 mark. Okay, another 1 mark. And then what else? Okay, so you calculate the percentage of error. So this is the equations, and then you have the calculations, right? You have the calculations. So done, okay? So that is how you should do your calculation. So this is a very complete calculation, and this is what you should do in your actual report writing. So start from table, and then go to the calculations of the centroid, and then the calculations of a gradient, and then the calculations of percentage of error. All right, percentage of error. And then the discussions. Okay, so discussions, I don't want to go through with you now. All right, so this one, I will read it after you submit it. Okay, now discussions, you guys don't keep PM me, okay? Because a lot of you like to PM me. Then in that case, what does it mean? It means I have to mark your discussion for 2 to 3 times per students. And I'm not only have a 1 class of students, you know. So jangan sentiasa PM tepi saya dengan discussions yang lengkap. Minta saya semak dulu sebelum kamu hantar. Then what is the point of submission? If I already check it, I've already marked it, then what is the point of submission, right? And when you submit it, then I have to go through it again, the same thing. All right, so discussions, you don't always PM tepi with a full discussion, ask me to check before you submit. All right, you just submit and I will check it in a Google Classroom. Maybe it will take some time, but I will check it, don't worry. Okay, saya akan tanda, cuma dia ambil masa sikit because this 2 weeks is a bit busy. Okay, but perhaps after next week, I'm very free. Okay, so don't worry. I will definitely mark all of your lab report, and then I will go through it with you guys. If there's any serious mistake and everything, I will put a comment there. And my handwriting in your report, okay, it might be a bit hard to read. Okay, so if you cannot understand, then you can ask me that one. Okay, why? Because I'm using tablet, and if I want to write with tablet, it's a bit hard. Okay, because my palm cannot touch the screen. So saya kena tulis dengan tangan macam terapung sikit. Okay, so handwriting saya memang teruk. Saya faham dalam write report anda. So if you cannot understand, you can always PM tepi and ask that one. Okay, sebab dia tak macam saya tulis sekarang, where my hands can touch the table. When I use tablet, I cannot touch the tablet because it's too sensitive. Okay, so it's a bit hard for me to write a very detailed comment in your lab report. So of course, in that case, if you got anything, you can ask. Okay, but don't ask me to mark your lab report before you submit. Okay, sebab itu kamu akan tambah kerja saya akan lagi tak sempat tanda semua orang punya kerja. Okay, so I think that marks the end of today's class. Do you have any questions that you would like to ask regarding the new format, regarding the following sections, and also regarding the pre-lab? Ada sebarang pertanyaan nak tanya?
No, madam.
No. Boleh faham? Okay, so anda cuba dengan format baru untuk eksperimen 4. Eksperimen 3, kamu siapkan ikut format lama and then hantar saja esok sebelum jam 5. And then kamu ada 24 jam lagi untuk siapkan eksperimen 4. Okay, so eksperimen 4 nanti kamu tengok and then guna format baru. Okay, eksperimen 4 guna format baru. So the next section, okay, our next select class, I will go through a few experiment 4. I will choose a few lab report 4. I will go through with you guys in a class. Okay, before you proceed to experiment 5. So next week punya lab, kita akan bincang experiment 4. I will select a few experiment 4. Okay, experiment 3, we are done. So I won't look at it anymore, but I will still mark the things that you submit in your Google Classroom. Just that I won't discuss it in the class. I will discuss experiment 4 with you in the class. Okay, so that's all for today. You may leave the class now.